All right, let's take a tour of one of nature's most incredible inventions, the digestive system. This whole thing is really a story about evolution solving problems, a wild journey from a super simple sack to a highly complex food factory. So let's dive in. It really does sound like the beginning of a bad joke, right? But the answer actually gets right to the heart of what we're talking about today. The thing is, all three of you, a bird, an earthworm, have found a unique and frankly brilliant way to solve the exact same problem. And that universal problem is this. How do you take something from the outside world, an apple, a seed, maybe another creature, and turn it into the energy and the building blocks you need to just live, to grow, to move, to be alive? So to really get this, we're going to climb what you could call a ladder of complexity. We'll start with the most basic blueprint you can imagine and see how evolution has tacked on new features. And it's not always about making something better, but about crafting the perfect tool for a very specific lifestyle and diet. First up, we've got the most basic design of all, the simple sack. Seriously, just think of it as a biological cul-de-sac. There's only one opening, it's the entrance for food, and it's also the exit for waste. It's simple, for sure, but as you'll see, it comes with some pretty major drawbacks. Now, even with this simple plan, nature finds a way to get creative. You've got a hydra, which uses these tiny stinging tentacles to grab its prey. But then you have a planaria, a little flatworm, that does something completely different. It sticks out a tube from its belly to basically vacuum up its food. In both cases, they start digesting in the main sac, we call that extracellular, and then finish the job inside individual cells, that's intracellular digestion. And here is the big problem. With just one opening, you can't really eat while you're still processing your last meal. Imagine a restaurant with only one door, and everyone, customers coming in, garbage going out, has to use it. It kind of works, but it's not efficient at all. To fuel bigger, more active animals, nature needed a better design. And that better way was a total revolution. The digestive tube with two openings. This one change transforms that dead-end sac into a super efficient assembly line. Food comes in one end, gets processed at different specialized stations along the way, and the waste goes out the other. This was a pivotal moment, allowing for a constant supply of energy to build bigger bodies and fuel more active lives. The humble earthworm is the perfect showcase for this assembly line. Food goes in the mouth, gets stored for a bit in the crop, then it moves to the gizzard, this really muscular part that just grinds it all up. After that, it's off to the intestine for all the chemical breakdown and absorption, and finally, whatever's left exits as waste. See? Each section has its own specific job. This one-way tube is so fundamentally important it gets its own name, the alimentary canal. And this basic blueprint, a tube with a beginning and an end, is the foundation that almost all the more complex digestive systems, including ours, are built on. And this is why it's such a massive upgrade. You can eat a new meal while the last one is still making its way through the system. This unlocks continuous feeding, which means a constant flow of energy. And that is the key that allowed animals to get bigger, to move faster, and to become way more complex. It's an absolute game changer. Okay, so once you have the basic assembly line, evolution can get really creative and start adding custom tools. And birds are a fantastic example of this. They took that basic alimentary canal and customized the heck out of it for a life of flight and a diet full of tough stuff like seeds and insects. I mean, that's the exact puzzle birds had to solve, isn't it? How on earth do you break down a hard seed or the tough shell of a beetle if you don't have any teeth? Well, evolution's answer is just a series of incredible, specialized adaptations. First up, you've got the beak. It's not just for making noise. It's this incredible, specialized, lightweight tool that does the job of heavy teeth. It's perfect for grabbing, for cracking, for tearing food apart before it even gets into the system. Next in line, a lot of birds have a crop. It's basically an expandable storage pouch. Food can sit in there for a while and get softened up with moisture. It's kind of like soaking tough beans in water before you cook them. It just preps the food for what's coming next. From the crop, food then travels into the proventriculus. You can think of this as the bird's version of our stomach. This is where the heavy-duty chemical work begins, secreting powerful acids and enzymes to start breaking everything down. And here it is, the genius solution to that whole no-teeth problem. The gizzard. This thing is an incredibly muscular organ that mechanically grinds the food. And get this, A lot of birds will actually swallow tiny stones to help the gizzard out, turning it into a powerful little stone grinder that can pulverize even the toughest food items. So, we've seen the simple sack, we've seen the specialized assembly line. Now, let's bring it all home and see how all these ideas come together in one of the most complex systems out there, our very own human digestive tract. Our alimentary canal is like the ultimate specialized factory. It all starts in the mouth with saliva. Then, the stomach acts as both a muscular mixer and a chemical vat, using gastric juice. But the real star of the show, honestly, is the small intestine. It gets this cocktail of juices from the pancreas, the liver, and its own walls to finish the job and absorb all those precious nutrients. We can actually break this whole amazing process down into 5 main stages. First is ingestion, which is just the simple act of putting food in your mouth. Then comes digestion, breaking it all down. That's followed by absorption, where the good stuff gets into your bloodstream. Assimilation is when your body's cells actually use those nutrients. And finally, egestion is just getting rid of whatever's left over. And here's another mind-blowing feature. To make that absorption step super efficient, the inside of the small intestine is lined with millions of these tiny, finger-like things called villi. All together, they create a massive surface area. We're talking about the size of a tennis court, all to make sure we soak up every last bit of goodness from our food. But of course, not every animal plays by the same chew and grind rulebook. Nature absolutely loves to bend the rules, and you find some really fascinating feeding styles that just bypass parts of this whole process. I mean, you've got filter feeders like mosquito larvae that just sift tiny bits of food out of the water. Then there are fluid feeders like an adult mosquito that literally drink their meals. And then you have the ultimate shortcut, parasites, like a tapeworm. It just hangs out in its host's intestine and absorbs food that's already been digested. It's so efficient, it's actually lost its own digestive system over time. So when you look at the whole picture, the main takeaway is this. Whether you're looking at a simple sack or a complex, customized machine, the story of digestion is just a masterclass in how evolution solves problems. It's a beautiful, beautiful example of how life adapts to meet that one fundamental challenge, turning food into fuel. Which, leaves us with a pretty cool final thought. This system has been changing and adapting for hundreds of millions of years. So as diets keep changing, as environments change, as animals themselves continue to change, what new and incredible solutions might evolution come up with next? What will the food factory of the future even look like?